So today we're going to focus on really the very basic components of any statistics class, and that's really some of the initial displays. What we're going to really focus on, types of variables. A big one today is ways to describe and compare distributions, but then underneath we talk about different types of displays. We're going to talk about Dotplots, Stemplots, and histograms. So without further ado, let's jump right into types of variables. When we look at variables, really, it's just categorical variables and quantitative variables. Categories, different political parties. That could be an example of a category. Gender, are you a male, female? What year are you, let's say, in a college or in a high school? Are you a freshman, sophomore, junior, senior? Now, quantitative are different variables where we can actually add them together. Maybe weights in a class, how many hours of TV you watched last week, yearly income. Now, sometimes you can have a little bit of crossover. For instance, yearly income might be a type of category because you might be talking about lower class, middle class, upper class. So it is important to really read the entire context of the problem and make sure you understand, are you looking at categorical variables or quantitative variables? And as we move throughout this course, the type of variable will be very important, especially when we get into least squared regression lines, chi-squared tests, and different parts of statistics. So make sure you do understand the different types of variables. Now, when it comes to describing a distribution, it's really a four-step process. And what we're looking at a center, we're looking at a shape, we're looking at the type of spread, and we're looking at different outliers. Now, first of all, with regard to center, we're either talking about a mean value, which is adding up all the values and dividing by the number that you have, or we're talking about the median value, which is the physical middle value when they're arranged from least to greatest. These are usually determined based on whether or not really with the shape. And we'll get into that in more detail, but the most important thing I can bring up now, don't use this word average anymore. The word average is really what people not in statistics class use. Let's talk about shapes a little bit. Roughly symmetrical. That's pretty much what you're thinking. That's a graph that can look maybe like that. That could be a roughly symmetrical graph, meaning that it's the same on both the left and the right. However, there are other graphs that look kind of weird that can also be described as roughly symmetrical. I might have a graph that's called bimodal. That could look like that. Or I could even get more complex and have one that's almost trimodal. That could look like that. So these are all examples of roughly symmetrical, but when we talk about a shape, we're looking at, are they the same shape on both sides of the reflection property? Now, skewed right and skewed left, it's usually better to describe these in terms of context the first time. For instance, let's talk about a skewed right graph. That's where most of your data would be on the lower end, but then something is skewing it to the right. A good example here, imagine a class of cute little kindergartners, and let's say we're looking at their weight, and they all weigh right around 50 pounds. We'll say 50 to 60 pounds. But then we have this very large male teacher who's up here, and he weighs 250 pounds. He would skew the data to the right, therefore the shape of this distribution would be skewed right. Skewed left, pretty much the other way. That's where you have data that's mostly pooled to the upper end, and you have one value down here. Let's say you gave a test that students did very well on, and let's say these scores were all between like 85 to 95%. And the kids did great on this test. But there was one student down here who earned a 12%. That 12% score would skew our data to the left. So again, roughly symmetrical, skewed right, and skewed left. Spread, we can either call it by the range, which would just be the distance from that minimum to the maximum value, or we can also use variance. We'll get into more detail in how those can be used as we go out throughout the course. And then outliers, right now we're going to talk about outliers solely from do they look out pretty far out there. There is a mathematical formula that we'll learn later, but for right now, we're just looking at eyeballing something that seems pretty far out there. But when we describe distribution, center, shape, spread, outliers all need to be discussed. Now, let's talk here for a moment about a dot plot. This is a nice one here. This is a quick way to show data in a graphical display, since we're talking about different ways that we want to have our data appear. Number of goals in the first round of a high school soccer playoff. That's what we're looking at right now. And how I'm going to do this one is I'm just going to go down the line, and you can see I'm going to go 5, 0, 1, 0, 7, 2, 1. So I'll put a dot at 5, 0, 1, 0, 7, 2, 1. Now, one thing I want to do is I do want to try as much as possible to keep these on the same level. What would be very misleading is to have one column look like this, and then another column look like that, even though they both have 4. So we are going to want to make sure that we try to space these out as much as possible. So then the rest of these, again, 0, 4, 0, 3, 0, 2, 0, 3, 1, 5, 0, 3, 0, 1, 0, 1, 0, 2, 0, 3, 1. So that's just a quick way for us to take this data here, which we might not have been able to tell very much, and get a quick look now. And then what we can do is talk about describing this distribution. This is the distribution of the number of goals in the first round of high school soccer playoffs. So let's discuss this in some more detail here. Where is the center? So if we look back over here, well, we can see that there are 28 values. So the median of that would be the 14th value, right there between the 14th on this end and the 14th on this end. So I can sit there and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So right around there is my median. So right here we can say the center is a median equal to 1. What kind of spread does it have? Well, it has a minimum of 0 and a maximum of 7. So we can say the range equals maximum minus minimum. So this has a range of 7. Now how about shape? If we come back over here and look at this one here, we can see this is not symmetrical. This, if anything, appears to be more skewed to the right. So when we talk about this shape here then, I would recommend calling this one skewed right. And do any data points stand out from the norm? Right now, 7's pretty far out there. So 7 is a possible outlier. Now again, we'll talk about a mathematical formula for that later, but for right now we'll just say that's a possible outlier. And there we go. 4 ways we describe the center, the spread, the shape, and the outliers to describe the distribution. So here's a quick little quiz for you. The following graph represents what type of shape? So let's go through this and think about it for a moment. Now, well, you might think, let's start at the bottom here. The minimum is 1 and the maximum is 12. So this we could say has a range equal to 11. But that's not about the shape. That's about the spread. So it's not that. The center's at about 4 seems possible. But again, that's not shape. So then we're left with roughly symmetrical, skewed right or skewed left. And again, we can see here that this one appears to be being pulled to the right, so the correct answer is skewed right. It is not skewed left, and it is not roughly symmetrical. Okay, here's a whole bunch of data from back in 1999 all about different types of soda and the amount of caffeine that was in it for 8 ounces. What I want to do is take all this data and show you a Stemplot. Now a Stemplot here, we're going to have the stem on the left side and the leaf on the right side. Very important with a title, extremely important for a key. Now, if you end up getting very large, long stems, you can get the skyscraper effect, and you can split that up into a 2-level stem plot if you want, and you'll see what that looks like here now. For instance, right now, this is our stem plot. You can see we do have our title, but what we don't know now is what does this value there represent? And that's why we need this. We need something here at the bottom. That's a key. 1/5 represents 15 caffeine, 15 amount of caffeine. Because otherwise, we don't know if 1/5, did that mean 1.5? Did it mean 1500? Without this key, we wouldn't know how to read it. Now here's the other thing. You'll notice this one does have a little bit of a skyscraper effect. It's just getting very long that way. So that's something else we can do, and that's where we can split a stem plot. Now when we split a stem plot, the first digit, this first stem would include the leaves from 0 to 4, and the second stem would include the leaves from 5 to 9. That way it does stay equal length. So you can see here, for instance, this value here represents 35. Just makes it so it's a little bit more manageable at times. You might be able to see some more trends. Sometimes we'll have a back-to-back stem plot. For instance, we can see here is something comparing males to females. What this is missing is the key. So for instance, I don't know what this 20 represents for the males, or what this 29 represents for females. So that's why a key is very important. Just wanted to show you, though, an example of a back-to-back stem plot. Now, here's a question from back in 2005 that was on an AP Statistics exam. And this one here, I'll let you pause the video so you can read it in some more detail. What it's basically doing is looking at the caloric intake of adolescents in an urban environment and a rural environment. And they took a random sample of 9th grade students from one high school in a rural area and another random sample of 9th graders from one high school in an urban area. And we ended up getting this. Now you'll notice they have the stem here. They say the 10s and the leaf is the 1s. So that's what they're using as a key here. Now, what this is saying here now, read a few sentences comparing. Now that word there is very important. Comparing the distribution of the daily caloric intake of 9th grade students in the rural high school with the distribution of the daily caloric intake of 9th grade students in the urban high school. So let's go back and think about this. When we see distributions, we're thinking again, center, shape, spread, and if relevant, possible outliers. But very important that we're talking about comparing. So let's look at center here first of all. We can say the center is somewhere down around here, maybe down around this range here for the urban school, while the center would be somewhere up here for the rural school. It's not as important to say the actual answer. So when we talk about center, we can say the center for the urban school is less than the center for the rural school. Regarding caloric intake. It's always important to use that context. Regarding caloric intake. Apologize for my handwriting. Again, I do like to have that just to make sure we understand we're talking about caloric intake here. But right now we're saying the urban school has less caloric intake than the rural school. So center, done. Let's talk about shapes. The rural school, the rural caloric intake is roughly symmetrical and the urban caloric intake is, now here's where we have to be careful. We can see there's a 2 here, and it goes up to 5. Most of our data is around 2, and then it trails down like this. So that's a quick way for you to see that the urban caloric intake is skewed right. Shape is done. Now let's talk about spread. The range of the urban school is from 26 to 42, which is 16, which is less than the range of the rural school, which was from 32 to 51, which is 19. Spread. Now let's talk about outliers for a moment. There don't appear to be any outliers here in urban, and there don't appear to be any outliers in rural, so we can just say no outliers are apparent. So let's just make sure we did this. We're comparing. Comparison words, more than, less than. Comparison words, larger than. Not comparison words, just listing them. If you just say the center for urban is about this and the center for rural is about this, you're listing, you're not comparing. So it's very important to compare. Okay. So the goal of this study was to compare the caloric intake. Is it reasonable to generalize the findings of the study to all rural and urban 9th grade students in the United States? Explain. Well, the question now is, was our sample from all students in the United States? No, our sample was from students in one high school in a rural area and another sample from one high school to an urban area. So is it reasonable? No, it is not reasonable. It would only be reasonable to generalize the findings to this one rural high school and to generalize the findings to this one urban high school. If you want to generalize the findings across the United States, they should have taken a random sample of students from across the United States in a rural setting and also an urban setting. Now, this is talking about here different plans. They're going to conduct a similar study. Plan 1, have each student in the study record all the food he or she consumed in one day. Then researchers will compute the number of calories of food consumed per kilogram of body weight for each student for that day. Plan 2, have each student in the study record all the food he or she consumed over the same 7-day period. Then researchers would compute the average daily number of calories of food consumed per kilogram of body weight for each student during that 7-day period. Assuming that the students keep accurate records, which plan 1 or 2 would better meet the goal of the study? And justify your answer. When answering these questions, I like to tell my students, tell me what plan is good and why, and then also tell me why the other plan is not as good. So let's talk about plan 1 for a moment. Let's say that one day is, let's say for plan 1, pretend for a moment that one day is Thanksgiving. Where again, I don't know about you, but I eat a lot on Thanksgiving. So based on that sole one day, there would be a chance to have a very different than what I traditionally eat on that one day, which could cause the number of calories to be very skewed, especially skewed here in the higher end. So by doing plan 1 and having one day where you eat a lot, you could very much skew the data. Plan 2, by doing it over a 7-day period, some days you might eat a little bit more, some days you might eat a little bit less, but in the end, it should all pretty much average out to what you traditionally eat. So based on this, what would better meet the goal? Plan 2 would better meet the goal because in Plan 2, high days and low days would tend to cancel each other out, where in Plan 1, we could possibly have one day that would skew our data possibly on the upper end. Now, what I wanted to do with this was really just to show you, these are some possible answers. Main thing was describing, but also talking about comparing distributions. And right now we talked about dot plots and stem plots. We didn't get to histograms yet, but we will in our next talk. So please make sure you take a look at that. And as always, let me know if you have any questions. Thanks for watching.